So hello, everybody. Welcome to the special event today on Closing the Loop. And thank you all for joining firstly. My name is Kashyap, or you can just call me Cash, and I'm from Aalto University. This event is organized by members of the HumaneAI Net project. For those of you who are unfamiliar with the project itself, HumaneAI Net is an EU-wide project that aims to bring together researchers from across Europe with a common goal of shaping the role of AI in our daily lives, also while paying attention to things like ethical values and societal impact. So the network consists of 53 institutions in total. You can see on the map, they're highlighted and they're spread across 20 countries. And if you'd like to read more, you can visit the website, the links displayed on the slide. One of the key features of the project itself is this concept of what we call micro projects, which are basically small projects where multiple institutes collaborate, multiple researchers from different places collaborate with each other on a particular topic that is relatively well defined in scope. And these micro projects typically have a short span of 1 to 6 months. And then the aim is to produce some tangible results in that amount of time and then build upon these micro projects as well. Again, if you'd like to know more about the micro project structure, I won't spend too much time today since we have an exciting lineup, but instead you can go have a look at the website and read more. So let's get into today's event itself called Closing the Loop, where we'll be discussing how and why humans and computers collaborate, interact, and form partnerships. The event is organized by Wendy Mackay from India, Antti, and myself from Aalto University. So if you have any questions, please feel free to drop us an email or contact us via chat or any other way. We have an exciting schedule for you lined up. Here are the speakers for today. We have 2 plenary talks, which will be about 20 minutes each. And we'll take like a short 5-minute break to stretch your legs, and then we'll follow that by 4 technical talks. And then finally, we'll also have extended panel discussion where all of you will be invited to participate, ask questions, and discuss with the speakers. So hopefully most of you can stay till the end. We aim to end at around 4 p.m. Central European time. So that's in about 2 hours from now. Just a few housekeeping points before we start. Please raise your hand on Zoom if you'd like to speak. You can find that option in your control panel below. And to avoid disturbing background noises, please mute yourself if it's necessary. Also, to be more engaging, we encourage you to turn on your video and camera if possible. And you can always post questions in the chat, and one of us will then post it vocally if needed. Just one point, the event is recorded, so I already started the recording, and if you have any objections to that, you can of course choose to mute yourself and keep your video turned off, but you can also contact me later if you wish to have some part erased for some reason. Okay, so that's about it. I won't spend more time on formalities, and we can get started with our first talk by Wendy.
Thank you very much. And thank you for doing so much of the hard work of organizing this. I'm going to share my screen now. And let's see if I can get this right here. Share. And all right. So I'm going to try to do this quickly. I usually do this talk in more time, so I will zip through it. But I think it's important to think about why we're doing HumaneAI, why we're thinking about humans and how they relate to intelligent systems. And I want to talk about the idea of a human-computer partnership. So I would argue, as somebody who comes from human-computer interaction, that we have a key challenge, which is how do we improve human interaction with intelligent systems? So this is not about what is the algorithm, but it's what is the interaction like between the human being and all of this diverse technology that is coming out in the world. Now, if you think about how we normally deal with interactive systems or computers, we have several different models. And so this traditional human-computer interaction model is really to think of the computer as a tool. So I, as an individual, use the computer as a tool to accomplish something, and I accomplish the task myself. The more traditional way of thinking about a computer from an AI point of view is the computer as a servant. So it accomplishes tasks for me. I delegate tasks and it does them, or it can watch me and do something and recommend something back and forth. And finally, of course, there is the computer as a medium, which is what we're all experiencing at the moment, which is communicating among people, but using the computer as sort of the mechanism for doing that. So then we say, well, okay, that's fine. That's been around for a long, long time as a way of thinking about how we organize our interaction with technology. But as systems become more and more intelligent, we have to think about what is the role of the human and what is the role of the computer. And in fact, what is this idea of a human-computer partnership? So I'd like to give you an analogy to give you a way of thinking about this. Imagine that we are dealing with technology that supports transportation. So if I don't know where I am in a city, or if I've been drinking and it's Saturday night and I want to get home safely, I can take a taxi. And in this case, I'm basically delegating the task of driving to the driver or to the taxi. Now, alternatively, I could enjoy driving. I could find driving a motorcycle, for example, something that's really fun and interesting and cool. And here I need to get skills. I have to get trained to do this. I have to get better at it. There's a lot of things I can do, and there's a whole progression that I have to go on, but I am in control. It's a very bad idea if I've been drinking on Saturday night to take my motorcycle home. I should take the taxi cab and just delegate that responsibility. But if it's Saturday afternoon, it's a beautiful sunny day, and I want to go out into the country, taking my motorcycle might be the right solution. So finally, we have a kind of shared model. And here the idea is that we have a horse. A horse is an intelligent entity independent of me. It could be my horse. It could be a horse that the horse and I have lived together for a long time and we get to know each other. The horse knows my riding style. I can teach the horse things. The horse does things for me. If it's Saturday afternoon, I can go riding with the horse and enjoy that. And if it's late Saturday night and I've been drinking, the horse can take me home. So the idea here is that there's intelligence on both sides and we remain in control as human beings, but there's a sharing of agency across. So that's the model. Now, when we think about a human-computer partnership, we have to think about how we manage this role of the intelligence system. Traditionally, when we talk about human in the loop, that's a very machine learning perspective. So if you're coming from a research or industry perspective with machine learning, you think about human in the loop primarily from the perspective of the algorithm, which is how can humans help me improve my algorithm? It's either training the algorithm or providing data to the algorithm or whatever. But there's an alternative perspective that you can take, which is what I like to call the computer in the loop. Here we have the same back and forth between the human and the system, right? There's an interactive loop. But now the goal is for the computer to empower the human being. And the measure of success is not, is this a better algorithm, but rather, is the human being better able to do something as a result of interacting with this computer? And the way in which the human being interacts with the computer is critically important. It's not just functionality at the end, but that interaction through time that is critical. So we have a number of issues. We want to focus here on interaction, not interfaces. So interaction over time. We want to think about how we let users stay in control of that interaction in a flexible way, in a way that can be reused. We want to let users develop expertise so that they don't have to constantly relearn their skills. And we have this notion of co-adaptive instruments, which I won't have time to go into detail, but I'll give you a taste of, which is the idea that we're separating the interaction from data and functionality in this idea of a co-adaptive instrument. And we treat interaction as a first-class object in the sense of a computer science sense of a first-class object. It is an object of study. So the phenomenon of co-adaptation. Now, many of you have heard coevolution This is coadaptation. Both terms come from evolutionary biology. I would argue strongly that coevolution is incorrect and coadaptation is the correct way of talking about it with respect to its insights. But basically, the phenomenon is users adapt to a new system, which means that they learn how to use it. So some designer designed it, and the users have to learn how it works. But at the same time, and what's really interesting is that people are always adapting new systems to meet their own needs. So they appropriate it and they change it. Some systems are easy to adapt, like a spreadsheet. Others are much more difficult, like an automated teller machine. It's not designed to be adapted. But the idea is that users do both all the time. Just a note about coadaptation. It is inspired by coevolution in biology and coadaptation in biology. And the idea is that you have organisms that change their environment even as they adapt to it. And the prototypical example is anaerobic bacteria, which change the atmosphere, making it possible for aerobic, meaning bacteria that breathe air, to emerge. So the ones that didn't breathe air give off oxygen, and then the ones that breathe oxygen can emerge. And we have the same kind of phenomenon with spreadsheets, where people take the idea of adding up sums of numbers and can transform that into a budget tool for exploring what if scenarios. What if I change this many inputs and do that many outputs? All right, so now what happens is when we're doing a human-computer partnership with an intelligent system, we have the notion of reciprocal coadaptation. So as we saw before, coadaptation is from the human perspective. We adapt our behavior to technology and learn it, and we also adapt the technology for our own purposes by appropriating it. But interestingly, intelligent systems can do the same thing. So they adapt their behavior to people, which is generally what we call machine learning, and computers can adapt human behavior, meaning we train people with technology or we persuade them. So positive and negative aspects of that. So we have a grand challenge here. We want to make tools that are incrementally learnable, which helps users kind of come up to speed over time. We want users to be able to control their tools and choose them, and we want to make them appropriable. So I just wanted to point out that when we deal with physical tools in the real world, we as human beings have a very easy time of it because we understand physical principles in the world. It's easy to learn, easy to appropriate. Current software systems are not like that. The rules are arbitrary and they change. There are certain conventions that we see, like swiping or pinching to zoom in and out, swiping to go from one slide to another. Those are conventions and they are not consistent. So what that means is that users are constantly relearning and relearning and relearning how to use a system, and every upgrade that comes along risks really disrupting and de-skilling the person. And by the way, if you do too much appropriation, you can break the system. So what happens is we have this very unpleasant interaction with a lot of learning new software where every upgrade changes the interface and we don't understand what an intelligent tool is doing. And if we compare that to our experience when we are learning a musical instrument, we can progress from being a novice, as you see on the left, to a virtuoso. We have Joshua Bell on the right. And the instrument essentially becomes part of the body. It's like riding the horse. It becomes an extension of who we are and what we're doing. And we really create a much more integral partnership. So the question is, how do we do that with interactive systems? So we want to create co-adaptive instruments that are worthwhile for the user to spend time and energy learning them. We want to make them accessible, they should be understandable, and they should be adaptable for new situations. All right, so that's just a summary of what we just said. And I want to show you 4 examples quickly. I think I can do it. And let me just zip through them. These are human-computer partnerships in a sort of really focused category, which is what to do with a mobile device. So what we have here is a situation where we have, normally I would be showing you me holding the phone. Your smartphone is extraordinarily clever. It can do all kinds of things. It's a computer that matches what you could do 20 years ago on a large mainframe. And as a human being, you have rich cognitive and sensory capabilities, but interaction with mobile phones is extremely limited. Basically, all you can do is tap, drag, swipe, and pinch. And almost all interfaces designed for phones are about consuming information with this very simple interface. It is not like, if you think about it, if you spent the time that you spend on your phone every day, or an iPad or whatever mobile device that you have, if you spent that same amount of time playing a piano, you would get very, very good at the practice of playing a piano. But you don't have that when you're learning your phone. You just tap, drag, swipe, and pinch. Now, if you compare that to the ways in which we deal with physical objects, and we can really develop expertise. So the question is, how do we turn a phone into something that is capable of a great deal more creativity and expression? So part of the problem is we need to learn how to do things. And to do that, we need to keep in mind that people learn over time and that they want a dynamic partnership. So we create these progressive algorithms that reveal intermediate recognition states. So imagine that I have a system where I have gesture-based interaction, where every gesture is mapped to a command. Here we see print, and I can draw the print gesture and it will print things for me. Now, what's interesting is that you want a system where experts just do the gesture. They don't think about it, they just do it. And that's very fast and easy. But that novices, when they hesitate, get some help. So help indicates to the system that they need a little more information. And we can provide them two kinds of dynamic guides. One is feed forward, which shows the current available gestures. And the other is feedback, which shows what the recognizer already sees. So let me show you this. So this is the help command. And what you see is if I pause and I want to get to the help, which is this question mark in orange, then I draw it and all the things that are not correct disappear. So I can hold there and you see there's different possible paths. I follow the orange one and it shows me that I can do that. Now, just here in novice mode, I start, I pause, and it shows me all the possibilities. In intermediate mode, it just shows me at the point when I pause, and if I'm an expert, I just do it. So the idea here is, continue, yes, okay. So that one shows us how do we go about learning, learning quickly. The next one that I want to show you is something that's much more about creating expressive output. Right? So most of the systems we have create the same output. So if you're using your mobile phone and you want to tap on your keyboard, you can write the word pepper, if you just tap on it, you'll get all of these words pepper here in the same way. If you use gesture typing, the system is extremely clever and it's able to identify different patterns. So basically you slide from the P to the E to the P back, and you dwell on the P and then you go back to the E and then you go up to the R. And there's different ways of drawing that. And all of those help you get to that one word. So it helps you find the one correct word. So the output is identical, even though the input is dramatically different. So what I want to show you here is expressive keyboard.
Swipe keyboards enter text by drawing a gesture through the letters of each word. The system guesses the correct word, even if it's drawn in different ways. Here, straight, curvy, and kind of crazy. But the system throws away these variations. What if we could vary text as we type to create rich, personalized output? Expressive keyboard keeps the correct word, but also recycles the variation in each gesture to create rich output.
So you see the cake has changed. And here she's going to do a really elaborate restaurant tonight. And so you see the change in the output. So here the idea is that I as a user can dial it down so it's just doing basic text the way I normally do it. But if I'm talking to friends and family, I can come up with a whole different set of fonts and different ways of expressing myself through the detailed personalized gesture that I've got. And you can also think about this as if I exchanged phones with you and we both typed the same message. Right now, nobody would be able to tell that it was me who typed it or you who typed it. But with expressive keyboard, the way that it looks is going to actually capture some of the personal variation of the individuals who typed it. So another one, if I can make this go forward. Now, what happens if you want to create your own gestures? We've taught you with the Octopocus system how to learn gestures that are already in the system. And you've seen how you can make gestures with respect to a keyboard that provides different expressive output. What happens if you want to create your own gesture commands? Now, to do that, what you want is for it to be easy for you to remember, but also easy for the system to recognize. And those are not the same thing. So we created something called Fieldword. Let's see if I can get this going.
What if we could choose easy to remember gestures and check whether the system recognizes them?
So here,
to register a new command, I type timer, and Fieldword displays a colored background that changes as I draw. Progressive feed forward helps disambiguate gestures. Gestures that end in a purple zone are ambiguous. It's safer to try again. Gestures that end in a red zone already exist. Either continue drawing or try again. Gestures that end in a blue zone are unique and easy for the system to recognize. What if this gesture already exists? I can try something completely different, or I can draw into the blue zone to make it recognizable. Fieldword can also reveal how the recognizer works. Here, an upward stroke might turn red, while a downward stroke stays blue.
So what we have here is a situation in which the user is both proposing gestures and getting feedback from the system. The user does not care how the algorithm works. What they care about is what is the system recognizing of their gestures and which ways that they draw work. And then they learn characteristics, like in this case, this particular algorithm is sensitive to the direction of it, of the gesture. And finally, if I can go forward here, the last one, almost on time, is command board. So we've got various ways of using gestures and keyboards in order to create a learnable, incrementally learnable system that allows us to do expressive output and generate our own commands. And now what we'd like to do is to be able to take advantage of the entire command space that's available on the phone. And we do this in a very simple way. We basically say that instead of having the space above the keyboard as just output space where you just show, like the chat or whatever is going on up there, it becomes an interactive command space that uses gestures. And you'll see various features that I showed in the previous thing in the next slide on here. So we have different methods of interacting with the system.
Command board transforms the area above the keyboard into an input space for drawing gesture commands. What if we could execute any command with a gesture as we type? We can take advantage of the soft keyboard to generate and execute commands, giving us the power of a command line interface on a mobile device. Command board offers different techniques adapted to the user's knowledge and skill to issue any command available on the phone. For example, if I know the doodle command, I type doodle followed by the execute gesture. Now I can draw over my text. The gesture shortcut technique lets me change the format of the current word in a single gesture.
So these are all different gestures that are associated with bold, italic, strike through, and underline.
What if I forget the gesture? I pause, and the Octopocus dynamic guide appears.
And so this is how I can learn to do
Command board offers the full power of a command line interface through gestures on a soft keyboard.
Okay, so I will have to stop there, but, and I'm not sure, do we have time for questions now, or are we going to do that later?
Let's do about 4 to 5 minutes of questions now. And maybe we can take the more general ones to the panel discussion after that.
Okay, good. I will stop sharing my screen and turn back into a face. If I can get my mouse. Oops, my mouse has.
I can do that for you. Yeah.
There we go. It's fine. Good.
Nice.
So, any questions?
Yes, thanks, Wendy. Great talk. Really cool to see some of these stuff, projects that you worked on. Everyone, please go ahead, post your questions or raise your hands directly and speak them out. And we hope to take the more general ones to later. So meanwhile, maybe, okay, I already see Andres has his hand up. So go ahead, Andres.
Thank you. I see this as a complex typewriter. Well, how much is it more than a complex typewriter?
Does your typewriter let you change fonts and do all those things? Does it let you?
Yes.
Okay,
Why is it more than that?
Because of the interaction. I mean, the whole point of it is not the function, as I was saying, but the interaction in time. So as I'm doing things, instead of stopping and going and looking through a menu, I have the ability to do it in the gesture. And I have the whole range of gestures that are available to me that can be associated with commands. And so everything that you can do more slowly and more in a more cumbersome way. So we're not talking about adding functionality. I mean, yes, typewriters do for typewriters, but do you use a typewriter, everybody? How many of the people who are listening here still use a typewriter? I mean, I did when I was in college, but I haven't done it. It's been a long time since I was in college. So the fact that I can accomplish the thing, it's fundamental to what I'm trying to talk about. I'm saying that the interaction with the user to the system over time matters a lot. And the fact that the final thing is, I can use a laptop, right? And I can create something, but the idea that I've got it all here in the interaction with the system and it's in partnership with me and that I can define it and I can choose how I interact with it and I control it and I can understand what the algorithm is doing as it's giving me feedback is critical. And the fact that if you just kind of wipe all that out and say, well, I don't care what happens to the user in this, they're just going to move their fingers and all I care about is the output, then you're back into the first one, which is we only care about the functionality, not the interaction with the system. So my challenge is not about the functionality. The thing is, what does the interaction look like? And these are examples of ways that you could modify interaction. And it's not the only area that we've worked in, but I mean, it's easy to do in a 20-minute talk. It's to kind of show you these particular styles of interacting.
Yeah, absolutely. I think the functionality versus interaction challenge is a very interesting and general one, and we could take this to the panel discussion as well later. Let's try to get a couple of more questions. We have Michael first and then Gabriella.
Thank you, Wendy. Of course, you know I love this. And so I have a predictable Michael question, which is, so you decide to make a new gestural command. Can you teach that to me? Can your phone teach that to my phone? How should that work?
It's an interesting question. So in theory, yes. Does our current prototype let you do that? No. But what you would be doing, what you've got is basically a command set and you have a gesture set. And in fact, what I didn't show you is that users actually start developing command grammars. So you have like verb type gestures and noun type gestures, and you put them together, and I can have call or Skype or text mom, dad, my brother, and I get this nice generative gesture command thing. And I would love to be able to send that to you. So I have other students who've been looking at ecosystems of command-based systems. Carla Grigio does some really nice work on that. And so in principle, you should be able to do that as a shareable thing. But I also agree with you that that is actually a major research topic. It's not something that we've addressed here. So in principle, I think yes, but it would be harder than it sounds, and has a lot of interesting challenges, because if you have different people who are working in different styles of interaction, and then they come together and they want to collaborate with each other. I've seen this happen in the field, when in field studies, where you have people moving from one group to another and they have to start adopting each other's things. And so what's nice though about a field word type thing is that you should be able to make both commands available. You could have a transition from one to another, but there's a whole bunch of super interesting questions there. So great question, thank you.
Yeah, I'm thinking, just a quick follow-up, sort of a context collapse of gestures. If I'm a member of 3 communities, I might need to know which community this gesture came from, because I don't even know if it's intelligible or makes sense to another community. I'm talking too long already. You need to hear from other people. Thank you. That was great.
Thank you. And then I think Gabriela is next. Hi, Gabriela.
Yeah, hi, Wendy. My question is very in line with what Michael just asked. I was wondering, from the researcher's point of view, how can we deal with this learning of gesture? How can we convey the gesture to the user? Maybe if you can tell us more on that.
Well, I mean, we have this kind of idea that was initially inspired by marking menus. Gord Kurtenbach and Bill Buxton did this way back when, and then we did some more work with Olivier Beau for the Octopocus, and there's been a number of people looking at incremental learning. And one of the challenges is to detect when somebody needs to know something. When do you give them help and when do you not? And so the very clever idea of the marking menu in Octopocus is if the user pauses as they're starting to do something, then that's an indicator that they want something. So you don't want to prevent the expert from doing it quickly, but you want to give help to the person and they need an indicator. We did another project with Andrew Webb where he identified, he was looking at people working on table-based interaction, and he saw that they naturally raised their hands, they hovered their hands above the table when they were sort of ready to use a certain set of commands. And then when they put their hand back on the lap, they were done with that. And so there's other kinds of physical things. Fanis Tsandilas has also done some things about, like, if I can't do this, but if I pick up this mug like this, you see that I'm about to drink it. But if I picked it up like that, which I won't because it's got tea in it, I could put it on the shelf. I would turn it up. So there's, as a human being, we're indicating what we're about to do through our actions without consciously thinking about it. And some of that can be taken advantage of when we're trying to figure out how do we interrupt without interrupting. In other words, how do we give people help when they need it, but not bother them when they're not? I know that's not a full answer, but we don't have a lot of time, but it's a great question. And I think it's one that really deserves some thinking. But, and again, this gets back to, I didn't want to kind of jump on Andres really so much, but it's really this whole issue of interaction over time is something that we don't pay enough attention to. And it's interaction while you're learning, interaction while you're adapting, interaction while you're trying to change your mind about it, when you're sharing it. All of that stuff can be treated as a first-class research question and not a sort of outcome of what's going on. So I think I should stop there, but thank you very much. Those were great questions.
Yeah, absolutely. The topic of learning and how systems can support us in doing that actively is super interesting also to me. And I think we can also take that into the panel discussion later with everyone else. Okay, so let's stay on track and move on to the next plenary with Jacob and Janet.
So thank you very much, and thank you for the invitation, and Wendy for giving this both this good introduction that I can follow up on, and for the conversations that we've had over the last year to really shape some of the ideas that we're going to be presenting. So Wendy presented some really fantastic applications of intelligence systems interacting with humans, and at the same time we've also heard from the news stories about how AI can be transforming the society, and what we're aiming at in our research center is really to see whether we can establish a framework for that kind of interaction that sort of is interdisciplinary in the dialogue of the potential of the AI. It's useful for the practical applications that Wendy talked about, and it sort of puts in context some of the discussions that we've had in a more general nature about the potential of AI. So one of the, I'll give a couple of examples just first, and one of the examples of sort of AI that is extremely useful, has been used in great success, but also has been at the amount of a lot of hype, is generative design. That sort of by many is sort of being announced. That's sort of the way that product design of the future is going to be happening. So the idea with generative design is that you have some algorithm, you specify the use cases or the boundary conditions of it, and then within those boundary conditions, the algorithms can come up with thousands or millions of different design suggestions, and the work of the designer is then to pick out the right ones and then produce the results that would be very, very difficult for any human designer on its own to be designing. So here's an example of lifting a monitor and then just generating a lot of different use cases that you as a designer can then assess. So that's really exciting, and it's been used a lot. And so the question is why we're really excited about going into discussions with Autodesk, who sort of are spearheading this on a commercial scale. And that is because the other side of it, that dialogue, is that there's applications, there's hype, and there's criticism. And some of the criticism says generative design is doomed to fail. And there's a number of different reasons that are sort of quoted, for instance, here. But one of them, and most prominent, is designers really don't work that way, which means that the interface does something or transforms the task to something that takes all of the skill set out of the humans. And that's why, following up on what Wendy said, we really need to make sure that those interfaces are adaptable, what we will call hybrid intelligence solutions. Another very brief example of some of the areas that we work in is in an image processing company for house sales called eSoft, and they have a development of image processing unit in Vietnam that takes images that are shot, for instance, in Denmark, transforms them and sends them back. And the obvious question was, in the age of AI, can we do something to enhance the efficiency? And they did that. They had a project, it enhanced the efficiency by 40%, and it was fantastic. And one way to say, what should we do as the next thing, is to say we should have another industrial PhD to get the last 60% and fire all of the 800 people in Vietnam. That would be the AI approach to this. But it turns out that this project in Vietnam is actually financed by something called DANIDA, which is a foreign aid program, because most of the employees in Vietnam are disabled. So it's actually not in anyone's interest to get rid of those employees in Vietnam. Rather than that, we would like to sort of work with them and discover sort of what are their workflows and how can we enhance their workflows to make them more efficient. So this is just an example to show that efficiency is not always the only parameter on which we should be measuring the effect of our actions. So that's what we investigate in the Center for Hybrid Intelligence in Aarhus University. We have a basic research division with some natural science investigations, social science investigations, mixing that together to form hybrid intelligence. And then we have applied units within education and corporate settings. So this is something that we do in a very interdisciplinary sort of endeavor with both at Aarhus University researchers from all faculties, but also collaborators from around the world. And when we talk about hybrid intelligence, one of the things that we've been very fortunate about is over the last year to be hosting a roundtable series with extremely intelligent and capable people around the world from different fields. And what I'll be saying now is sort of shaped a little bit and to a large extent by what they have said. Wendy is a prominent one of these. So taking a small step back and saying, okay, how can we relate the debates about AI that are sort of in the popular debates to the practical applications of AI? So many of you are familiar with the concept of the singularity. At some point, we have evolving algorithms that become more and more powerful, and at some point, you know, they can surpass humans either on small parts, but on larger and larger parts. And this process is really something that Wendy talked a lot about, human in the loop, and this, from a computational point of view, is then the task of taking algorithms from being in the loop, where the human is integral in solving the task, to putting humans on the loop, where they only verify, and then dream of putting them out of the loop in the end. And of course, this is sort of a programmatical dream, but in a practice, it can also be a nightmare for a variety of different reasons. And one of them is the de-skilling that Wendy talked about. When we take the agency out of the human, then we change the work practices, and de-skilling is something that can happen. Another thing is that the question is, how is it that we can make sure that the AI that we are building and that becomes more and more increasingly agent and powerful, has increasing agency, that it aligns with our goals? And one of the first researchers that sort of looked into this from a computer science point of view was Stuart Russell. who sort of stated that many of these algorithms, the intelligent algorithms that we have, are defined sort of in a, let's say, reinforcement learning paradigm, where we say first what it is that we want the algorithm to do. That is called the cost function. And then the algorithm learns how to find solutions that improve or that improve this cost function. So what the problem with that is that as humans, we are not really always capable of explaining exactly what it is that we want to be the result of an algorithm. For instance, when we put smart algorithms into complex settings, consequences can happen that we didn't foresee. And that's a problem if you have set all of the goals in the algorithm from the beginning. And that's why he and other researchers have introduced the paradigm of inverse reinforcement learning. And inverse reinforcement learning is then, rather than saying that we imbue the system with goals, then we imbue the system with curiosity about finding out continually what the goals of the human are. So that really speaks in line with what Wendy said, that we should have a system that is always curious about what it is that the human actually wants in this process. So that is then something, it sounds sort of a little bit abstract, how can we do it? But we could in principle do it. One way is to build these assistant type games in which the algorithm periodically polls or presents options then to the human, and thereby improves the match between what actions it serves and the evolving, perhaps, preferences of the human. So that's a way, both in a long term, that as we have increasingly powerful algorithms, we can keep them in line with what we want, but also in a short term, it points to the importance of that partnership that Wendy also talked about. And from a sort of popular point of view, there's been an increasing debate again about this sort of the power of the algorithm, the threats of the algorithms, and it has led a growing number of people to sort of focus on explicitly and sort of publicly saying how limited current algorithms are in their capabilities in order to spur evolutions that sort of link those two together. And one of them is Gary Marcus, who really pointed out, saying, just because something appears to be intelligent for a moment or two doesn't really mean that it really is intelligent. So we need to discover the difference between apparent intelligence and real intelligence. This is also something that became sort of clear in the Nature paper a couple of years ago, Deep Trouble for Deep Learning, which sort of very famously showed these stop signs that if you present just a couple of stickers on it, then it becomes interpreted as a speed limit 45 miles per hour. Very, very dangerous for our safety if we sort of put our lives in the hands of a self-driving car. So that really again shows that across all stakeholders, when we talk about implementing AI systems, we need to develop a language that allows also non-technical people to hear everything that's happening in the news and then make the connection to all of the fantastic applications that Wendy, for instance, talked about, in order to have a realistic perception of what AI can do, could do, and should be doing. And a typical sort of example of sort of the evolution or the techno enthusiastic and the techno realistic perspective is sort of Andrew, who says a mental task will more or less be programmable if it's done very quickly by humans. And Gary Marcus, who transforms that to say it will only be done if we can gather a lot of data on a setting which is not dynamically varying. So just drawing attention to all of the difficulties of making an algorithm-only solution. So that leads us then to what we mean by hybrid intelligence, and Janet will sort of take us through the definition of that.
Great, thank you. So here we come back to this figure. Previously, we focused on the left side where we were taking, moving from human in the loop to human on the loop to human out of the loop. And for the rest of this talk, we'll be focusing on this other direction here, this other axis, hybrid intelligence. And I'd like to again reiterate something that Wendy said. She focused on this interaction and not just the computer, not just the human, but that interaction. And so in hybrid intelligence, there's also this big focus on the plus sign. If you have human plus AI, it's the plus sign that's really so difficult to understand. And so when we're looking at hybrid intelligence, we need to pay particular attention to humans as a full psychological being, So intersubjectivity and theory of mind between humans and among humans, and between humans and AI. Mutual learning, this is something I'll come back to several times today. Mutual learning between the human and AI. So both parts are learning over different timescales. Interdisciplinarity, so interdisciplinary in collaborations for developing these types of technology, co-adaptation, and then the big plus sign between humans and AI. Previously, over the past decade or so, hybrid intelligence has been used quite loosely in many different capacities. As part of the work we're doing at the center, we are emphasizing a need to have a more stringent framework in order to operationalize hybrid intelligence and thus take these criteria into action. So when we're developing technology and use cases, it's important to understand what delineates hybrid intelligence from other forms of human-in-the-loop AI. And we adopt the criteria for hybrid intelligence from Dominic Dellerman, who's part of this hybrid intelligence consortium. So this has 3 criteria. The first is collectiveness, that the human and the AI are solving a task collectively. They're working on the same problem. Then there's solution superiority. So this socio-technical system achieves a result superior to that than either the individual human or the individual AI. And then lastly, the big point here, mutual learning. So the system is improving over time, both as a whole and as individuals. And so then we really have to flesh out, what does it mean for the human to learn? What types of human learning is happening, and what types of machine learning is happening? It's also been mentioned a couple times here, de-skilling, and I'll reflect on that in a moment. In most companies, when you have a new technology that you want to introduce, it's typically in order to increase productivity. So increase productivity of both individuals as well as the organization as a whole. However, often there can be unintended consequences or side effects from introducing this technology if it's not designed and implemented appropriately. And then you can actually have a decrease in productivity as the individuals lose skill sets or are de-skilled, or they don't have the opportunity to continue developing skills because of an over-reliance on the technology. And so right now, in a paper that we're working on also with Wendy and a couple other people in the audience, Arthur Yorth and Constance Kampf, we're working on a paper called De-skilling, Reskilling, and Upskilling, a case for hybrid intelligence. And here the goal is really to understand more deeply the role of the human in all aspects of the job cycle. Where the problem can be that maybe many companies have short-term or profit-oriented focuses, and so they can't overcome this productivity gap in order to invest in long-term solutions. And so that's one of the pushes for organizations like HumaneAI Net in order to have these types of dialogues. So in this paper, we present 6 questions for developers and decision makers to consider in their AI systems. So first, is the AI process human in the loop, human out of the loop, human on the loop or human out of the loop, maybe even computer in the loop also as an addition? Does learning occur, and does it maintain the skills and the competencies of the humans involved? Does both the human and the AI learn? And then, of course, if so, what type of learning is it? Is it domain knowledge, tacit knowledge, etc.? And then is the human learning at individual, societal, or organizational levels? And then what are these timescales for and underlying mechanisms for these learning loops? So we present this as initial catalyst for dialogues on how to develop these systems. And so then it's important to reflect a little bit on the human mind, of course, and human learning. And for the past decades, many of us are familiar with Kahneman's System 1 and System 2, the different bimodal processing of the human mind. where you have fast and conscious automatic tasks and slow, conscious, effortful tasks. Well, in a recent work, this opinion piece, Machine Thinking Fast and Slow, provides a parallel to how machines think. And rather, they have heuristics as a mechanism for fast reactions and also rule-based behavior for slower processes. And so it's very important here to recognize that developing a parallel between how the human mind processes and how computers process will help us to more deeply understand the benefits of these optimal synergies. Another metaphor that we can use to describe different modes of cognition is the landscape metaphor. So take this picture here and imagine you're on your summer holiday in the Alps and you're trying to find the highest peak. You just want the best view. You have two options. One is to go up from where you are right now and hope that that's the highest point. And the next is to search the area and decide, okay, maybe I have an intuition that there's a better place to start. Well, algorithms must also balance between exploitation, so these small incremental movements, walking up the hill, which it's very good at, and exploration, so large jumps in the landscape. And humans are quite good at doing these large jumps, so creative leaps. We'll come back to the concept of creativity as well, but these creative leaps in a potential landscape. Another beneficial dimension to look at when considering hybrid intelligence in systems is the problem complexity. So here we have in this figure two different dimensions. On the y-axis, you have the complexity of the problem in the sense that on a very simple problem, both the problem and the solution are clear. And then when you get a little bit more complicated, you have a clear problem, but not a clear solution. And then in the most complex area, you have neither a problem nor a solution is clear. And on the y-axis, you have increasing difficulty of stakeholder alignment. And that's really where you get into what these so-called wicked problems are, like climate change and ending poverty, where not only is there no clear solution, but people don't even agree on it. And so you have lots of different stakeholders that are at play here. So this is really important when we think about hybrid intelligence happening at a global scale or in multiple parts of a solution solving process. So I believe both Wendy and Jacob have mentioned that right now, a lot of AI interactions happen in both the training of an AI and in processing of data. So we could either look at sort of a local level and see how to improve hybrid intelligence interactions in these individual phases like data prediction, judgment, action. Or we can step back and see how can we integrate hybrid intelligence into multiple aspects. And we shouldn't just do this because we can. It's certainly not to say that we should go to the extent of having hybrid intelligence in all these different phases, but it's important to reflect on why it would be beneficial and how we could do it at these different areas. So now Jacob will give a couple of concrete examples here as to ways that we can dive deeper into hybrid intelligence.
Yes, and so the question was, just very briefly for us, is can we define sort of a framework where we can have different axes to characterize these different problems? And what we talked about in the hybrid intelligence roundtable series were then a number of different cases that sort of placed themselves at various different locations in the sort of complexity map here. And I'll talk about just one of them as an example, going back to this embodied agents or the generative design, and saying, okay, so along sort of four different axes, either the AI tries to solve the problem alone, we have human in the loop, we can call the computer in the loop, the third one here, and then hybrid intelligence, and just sort of reflecting on what are the characteristics of being in one of these categories and which questions do we need to ask in order to proceed maybe to the next one, where we see, for instance, the human in the loop here is something like imitation learning, where the human is sort of not subordinate, but is really someone who just performs their good old tasks, whereas the major changes is happening on the agent side. And then another sort of example where the human is learning much more by interacting with a more or less static AI system. On one side, we know that we can have de-skilling or leaning on technology, and on the other side, we have a wasted potential because, as Wendy talks so much about, this adaptation, this personalization or hyper-personalization, maybe even, where it adapts to really the individual cognitive processes. So that leads us to the, we have maybe 2 more minutes. And Janet, if you want to go quickly through and then talk a little bit about creativity, which is your main project, then I think we can end there. Oh.
Sorry, briefly, at our center, we have for the past 10 years now been presenting complex natural science problems as games using crowdsourcing and citizen science. And from that investigation, we turned then towards understanding human collaboration and cognition and developing games and interactions to study those concepts on a large scale. And we've studied that ranging from predictive learning, individual strategy, collaborative search, game theory, and recently we have been working on a portfolio-based cognitive profiling corpus to study large scale or population scale cognition. And this is because we found that it's very important when we're talking about understanding both the human and the algorithmic components to understand how these human processes are occurring. So we're measuring cognitive skills such as executive function, visuospatial reasoning, response inhibition. These have been typically studied in behavioral labs and in psychology for a very long time. And thus we have a good point of reference for them. But based on this, we have dove into exploring more complex contextual skills such as creativity. And that's something that we have repeatedly talked about today. In many contexts, we say, okay, is an AI creative? Or can the AI help the human be more creative? But more fundamentally, we have to understand what human creativity is and know how to assess it. And there are a series of tests that are typically used now to study different creative processes and products. However, those different tests do not correlate well within each other. And so at the center, we have been developing a large-scale game-based portfolio with a range of different disciplines in order to drive a deeper understanding of creativity and in order to assess it at a large scale. In addition to standard tests, we have a series of games, one of which involves both human and AI collaboration. So it's a human and a GAN working together to blend images, where we're interested in understanding human control over the system and how much human control is necessary in order for a creative process to occur. And we hope that by developing these different modes to study processes of creativity, such as convergent thinking and divergent thinking, and also how does it change when it involves a human and an AI, we can begin to use this battery in conjunction with field testing, so in different scenarios. We have a spin-off of this project as well that we've done in conjunction with AI for Good, where we're using a blend of human creativity and GAN support in order to be a catalyst or a dialogue for discussions around the Sustainable Development Goals. So to allow everyone to blend images, their visions of what a future could be, and begin a large-scale dialogue on these topics.
So one of the things that we think is really exciting for the future is that we combine these sort of theory-driven investigations of creativity with the practice-driven investigations of creativity, for instance, that Wendy talked about, and that one can inform the other, let's say, that provide a framework for what creativity is. On the other hand, we still don't know what creativity is, so we need those practical tests in order to inform theory. And together, we hope that sort of we welcome all the kinds of projects and collaborations that people are interested in this group. We've investigated this with a lot of people. We thank all of our collaborators for all the insights that they had, inspiration they've given us. And again, as I said, we would love to be collaborating on small or larger projects in the future. Thank you.
Great. Yeah, that was a great talk. Thanks a lot, Janet and Jacob, for doing this. Let's take a couple of questions. Phil already has one. Phil, go ahead.
Yeah, hi, I'm Phil Feldman. I'm from the University of Maryland, Baltimore County. I'm really interested in this idea of population scale thinking because we have many, many human beings on the scale of millions interacting with single intelligences like the Google search engine, which is affected by the way that we search, that then affects the way that we search. And because this type of connectivity between individuals mediated through technology affects the way that we behave, I'm wondering if you're looking at that process. So when we put lots of people together in a single environment that are communicating, say, through search engines, and they don't know that they're doing that, and they start to be focused in a particular direction because of the search engine results, how does that affect the way the population thinks? How does it affect the limitations of the responses of the individuals in the population, as well as sort of the variance of the way that the population behaves, as opposed to, say, the same number of people going to a library unable to communicate in the same way?
I think so. So this is an extremely exciting question and a research field in itself. We have started to sort of try to put the tools together to be able to start to study that. I guess before us, or let's say that there are two different approaches. One is to take a lot of behavior and then try to infer sort of the underlying mechanisms from that. It works if you have lots of data and you have lots of processing power, but it doesn't sort of come from a theoretical bottom-up framework. And it is also therefore difficult to sort of build into that framework. So what we are trying to do is take the question that you say, and then say, for instance, we had games that we had some problem-solving games, 300,000 people played it, but what we saw was that the individual approaches to interacting with that framework was so different that what we really needed was, in order to really understand it, we needed some a priori knowledge about which kinds of humans we were dealing with in that process. So I think that we can solve that, or we would love to investigate that, but the tools sort of are being able to sort of look into and categorize. Put it in a different way, it would be really interesting to see how bunches of people who have the same kind of cognition interact with the system, and then how that interaction sort of as a bulk goes into interactions with other kinds of people through those mediated through the interfaces that you talked about.
That's really fascinating. It's great work.
Yeah, absolutely. Thanks. Another question by Mark, and then we'll take a short break after that.
Yeah, thank you for an interesting presentation. I just wonder if there's a sense when you're talking about creativity, that creativity is something that you can't quite get at in study. And that if you, I mean, in certain way, getting at it in a kind of a deep study is feeding into this corporate, you know, parameter of can you turn creativity into productivity? Because you were talking about accumulated productivity and the relation of that earlier. I don't know, how do you see, in what ways do you see creativity not turning that way? Is there a creativity that is can be separated?
I think that's also a great question. One of the big pitfalls of starting to measure creativity is to reduce it to a single number and to measure the creativity. And one of the things that's what we are seeing happening to a larger and larger extent by corporate endeavors in this field. So we see corporations coming up saying, we can measure creativity for you as a company or as a state or as a university and give you the score for your employees. And they present a single number based on a task, which is then sort of a little bit pulled up like a rabbit out of a hat. And so what we are trying to do is do the opposite, to constructively fail. So that's why I was saying that we need to build a framework which is built to fail, in the sense that it is built to be tested in the real world and fail constructively and keep being built up as a more and more comprehensive framework. You could say adding more and more access and complexities and nuances to the skill. So that's at least our approach, not to reduce it, but to actually sort of embracing the complexity of the process.
Yeah, I think the relation of creativity with AI-powered systems is a really important and interesting one. I think we should also take that into the panel later on, because I'd like to also discuss that further. But maybe we can take a couple of minutes off now just to have a breather and then start with the shorter talks. Okay, I think we're ready. We're 10 past the hour. Let's start. We have a set of 4 talks, 10 minutes each. And I guess the best idea is to keep the questions for the panel discussion so that our speakers have at least 10 minutes to talk about their work.
Okay, so I guess I should start. Well, good afternoon, everybody. I'm Alessandro Saffiotti from the University of Örebro in central Sweden. And I must say I'm very glad for the previous 2 talks, because I think we are very much on the same line. So what I'm trying to show very briefly is the work we're doing in an interdisciplinary group, actually called the CREA also, on artistic co-creation and artistic performance, actually, of humans and AI systems together. Let me just check one thing before I start.
Front, center,
can you
front,
hear the sound?
center, side,
yes.
left, side,
yes.
left.
Okay, thank you, just making sure. So I'm going to give a little bit of background and tell what is our model of human AI collaboration and how we implemented in a proof of concept experiment for joint artistic performance, and give you a couple of examples of that. And I also want to spend 1 or 2 minutes on the evaluation of the collaboration in artistic performance, which is definitely not an easy issue to cover. So as I said, I'm very glad that we're all on the same page. So we already talked about the different ways in which human AI or human computer or human robots, in our case, although we take a very wide perspective of what we mean by robot, can either delegate the performance of a task to a robot or use the robot or the AI as a tool while performing the task, or the human and the robot can actually jointly collaborate in the performance of the task. And of course, we are interested, like other people said in the last part, like Wendy's partnership model. And the question we're interested in is how do we do the interaction and the collaboration between the human and the robot to do the performance of a joint, task. And we're actually looking at artistic performance as an ideal case where we can explore this interaction, because this is a case where the interaction is very visible, actually, is very clear, and how people do interact, especially in improvised and unforeseen situations. We especially focus on improvised jazz music in our case. And what we are proposing here is basically the use of AI not to generate music, for instance, but to really supervise and coordinate the interaction between the 2 agents. So what we're really looking at is a model in which a human performer and an artificial intelligence worker or agent or performing in our case are just 2 independent agents which are individually able to perform artistically by their own. But what we want to do is actually to use an AI system to modulate, to synchronize, to coordinate, or to mediate the performance of the two systems. And interestingly, we use currently this AI system to modulate the performance of the artificial system to adapt to the one of the human performer. But in fact, the human performer will by itself co-adapt, again, stealing the word from Wendy's presentation, to what the artificial performer is doing, resulting in a sort of closed loop. So there's a model basically where the AI system is not generating the artistic performance itself, it's just modulating the performance of an autonomous performer, a robot, again, in a general way, which is supposed to be reactive, meaning that the parameter of the robot performance should adapt to the expression, the artistic expression that the human is using in this moment, and may also be proactive, like the artificial performer may anticipate some change, may propose proactively some variation in the performance, which the human may or may not adjust to, accept, and adapt to, actually. I'm not going to give any technical detail in this short talk, just as a hint of the system we're actually using for our experiment. Is a system, basically is a model-based system. We're not using machine learning at this stage, where we encode the knowledge about artistic performance from music experts in this case, where we actually have a supervisory part where we generate parameters for the robot performance, for instance, the music performance of an artificial drummer in one example, parameters like the intensity, the complexity, or the different patterns that should be used, and so on. And we generate this parameter based on a number of expressive features which are extracted from the MIDI input of what the human is playing, actually. Features like the velocity or intensity, if you want, the rhythmic density that the human is playing right now, or the average velocity and density in the past, or maybe the delta of how it is changing in this moment. We also try to do anticipation. So we also try to predict values like maybe a climax at the end of a crescendo or something like that, which may be used proactively to actually say anticipate a change in mood by the robot performer, to anticipate actually, and to, or even to propose a climax during a crescendo or some other part. This has been implemented, actually, as I said, in a purely model-based way, using fuzzy logic for the time being, but again, is a first system. Don't want to give more technical details, just want to give a couple of examples of that to better understand. The first example is a case study when we actually use a live jazz pianist, which is improvising thing, and an artificial drummer, a standard one, like the one you may have on your mobile phone, but the parameters for the drummer are actually decided dynamically to adapt to the current expression of the piano player. So here is an example, actually, hope you can hear it. And here is actually an example where both the intensity and the complexity have adapted to the new style. Here is a little bit of proactive behavior where the drummer has increased the complexity a little bit, but the pianist did not follow up. So the mood is still quiet. Until this moment. Okay, and then I could probably go to a second example, which is similar to the previous one, but where we extend the system to generate parameters not only for the virtual drummer, but for a robot dancer. And once again, the robot is an autonomous dancer, which means that it has a number of pre-programmed dancing motions. What the system does is to decide the motion, to modulate the parameters for the motion according to what the piano player is doing. And again, it's improvised performance, so the system does not know beforehand what music will be played, not have any score. Okay, I want to spend one more minute, if possible, on the evaluation problem, because that's a big problem. How do we evaluate if is the collaboration work? How does the collaboration work, especially when we don't have an objective task to measure? We have actually a artistic performance as an objective task. And well, of course, we don't have a general answer to that, but the way we did it so far was, since we're talking about artistic performance, we basically look at the user perception. So we made, for instance, a user study with the number 90 participants that were shown videos with 3 different systems, where the real system with actually the dancer and the piano player coordinated by our AI system. One with a different pianist to make sure that the system was not overtuned on the particular piano player, and one where instead the parameters of the dancers were selected randomly, not the movement, because otherwise it would be really ugly, but the parameter of the movement. That actually looks like people did have the feeling that the pianist and the robot are actually performing together in good harmony with our system more than with the random system. And interestingly, the overall enjoyance of the overall performance was also better in the collaborative case. And that's it. The last thing I would like to leave with you is a question. Okay, this was in the case of an artistic performance collaboration. So the question, maybe the thing I'd like to hear your opinion about, maybe in the panel, is can a similar principle apply to human-robot collaboration beyond an artistic context? And that's it on my part. Thanks to the people in our CREA team.
Yeah, thanks, Alessandro. Great talk. Like I said, let's take questions at the end during the panel and move on to the next talk, which is by Janin.
Unmuting helps. Hi. Yeah, I think I just start here. Thank you very much for inviting me and for the great keynotes. And I think as it was already said, I think like many things will sound very familiar in my talk. So my name is Janin Koch. I'm a postdoc at INRIA Paris-Saclay together with Wendy. And I will present today 3 examples on how I and my colleagues actually developed visual design ideation tools using a little bit more collaborative approach, which kind of fits nicely in this topic. So now let's start with the idea behind it. I guess we all know the situation in the beginning of a project, may it be professional or personal, kind of like creating a party, that we're often searching for kind of new ideas or some kind of inspiration that kind of can trigger some new concepts. Well, according to the general understanding, you just have to spend enough hours under the shower and you will find the best idea for any kind of problem. Well, this is not really wrong. It's also not maybe the best way to get ideas. So, and according to creativity research, there are basically 3 main sources of inspiration in design. And the first one is internal sources of inspiration, which are basically based on your own experience of previous work, but also associations you have to certain objects or other things that you see also from your colleagues. The second one we are mainly familiar with, I guess, is our external sources of inspiration, which can be, of course, the random finds in art and nature, what we kind of hear often about, but it also includes the active search. For example, it's like being a similar task or similar situations, which is often used in professional creative practice. And of course, the last one is through collaboration and discussion, through disagreeing with our colleagues to kind of fighting for new ideas and coming up with new concepts. This, of course, in itself can be a source of inspiration. And for the sake of time today, I will only focus on some work we did, how to find inspiration through finding external material and through collaboration together with systems. So, especially, why is this important? Because in professional ideation, for example, in design, it is really crucial to find good ideas early on to an existing challenge or a need that we see, because the ideation phase at the beginning often defines all the approaches and all the steps that we are taking later on, and has a huge impact on the final product we're actually creating here. And in professional design, especially when we talk about like innovative problems where we might not have previous examples, we might not have this kind of like background, designers often turn to visual ideations, which is basically forming collage that might be digital or physical, as we can see here. And this is because pictures can sometimes communicate moods and intentions way better than words. And it also allows us to explore a little bit more alternatives beyond what is actually describable. That might be scribbling, that might be combining images and contrasting them to make an effect. And while being so crucial, there's actually not a lot of machine learning, high-level machine learning approaches available that are actively supporting ideation, especially visual ideation, as it's often related to rather tacit knowledge enclosed in these images. And as with ideation and creativity overall, we have the problem that we have constantly changing and evolving goals, because where we end up is usually not where we started in an ideation process. And this changes, of course, as soon as the goal parameters become a little bit more explicit, and we see way more tools that can help designers to work and think in these parts of the process. And I will now present some of our work that shows how we basically try to combine human and machine capabilities in a more interactive way to enable a more active collaboration for ideation in particular. And so some open questions we focus on, and I focus on today, was what does it actually mean to find ideas with systems? Can systems actually contribute their own ideas? And what role does such tools actually play in the process itself? So let's start a little bit by stepping back and thinking about how do designers actually search for external sources of inspiration, in our case, images, something that was actually mentioned before already. So when we observe designers in workshops, or we ask them through surveys how they look for inspirations, we saw that their ideas were often quite referential. So designers were looking for something like that, something similar to that and that, or in between, and had a hard time to actually use sharp descriptions, which are often required to use digital search engines for images like Google Image Search or Unsplash for designers. And according to our studies, it can actually take minutes to hours to find an image that depicts what you want using those traditional search engines. So how can a system actually work together with us to help translate our rather vague ideas into a kind of a machine understandable term, to kind of build a bridge between both? And to explore this question, we built a visual ideation tool called Semantic Collage, where designers could search using a normal search engine and also build a collage at the same time by just dragging the images on the collage board. Additionally, the system translates all visual materials or images on the board using a semantic labeling approach into a list of semantics, which it was ranked and subgrouped as, and a subset was then made accessible to the designers by actually attaching it to the image. That allowed designers to merge the meaning of images with text by just dragging it to the search, or even combining several images. But also the relevance and the semantic labels considered were displayed and could be adapted by the designer to kind of work with the system and find a meaning that is more intended for the search the designer had. With this interaction in the study with 12 professional designers, actually a majority said that the results were way more accurate to their thoughts, it was way more enjoyable, and they overall preferred this interaction. Now, so when we can have systems that basically can identify what the images are that we're looking at, we were wondering, can systems then not also contribute their own suggestions? And what would it actually require to do that? We kind of identified 4 crucial features for collaborative agents in the context of ideation we thought we have to solve. Number 1 is identifying what the visual space is about, including the material on the collage, which I kind of presented. Then the other one would be how to explore and exploit direction of ideas by itself, while also evolving with the designer in a more collaborative manner. As I said before, we usually end up on a very different point than when we started. And finally, how to communicate actually visual ideas. Because if you think about brainstorming, it's not about having a thought, it's also putting it in context of what you're actually talking about and how it's relevant. So in a project called HumaneAI, we address them by applying semantic analysis to get the semantic understanding of images, or we analyze the search patterns. And using interviews and surveys of professional designers, we also try to get a better understanding of what is the visual space we're talking about when we talk about mood boards. To explore own directions of ideas, we applied a cooperative contextual bandit algorithm to kind of explore especially the visual aspects, which observe basically visual features of a collage. For example, how colorful it is. And based on that, it has had probability distributions that pointed to either similar features, kind of continuing a visual idea, or very different ones to kind of explore something else. And with that, the system then combined it with the semantics said earlier to an image search and looked for a suitable suggestion to the current collage. These probability functions, however, were updated based on the designer's reaction, kind of like moving it on the mood board or kind of like asking for alternatives. And this allowed the system to kind of also learn preference from the designer and kind of move along with the creative idea. And we explained the suggestions with their relation, basically, how they're related to the collage. For example, how similar they're in color, or how relevant are the semantics to what you're currently working on. In a study with 16 designers, we saw that 25% of the final images on the collage were actually contributed by the agent. And that led several designers to report that the AI sometimes was a little bit more like a collaborator that brings fresh ideas. And with that, I actually come to the last point. So in our last study, we then said, well, if we see all these benefits of systems, what is actually their role of such interactive tools on a realistic, for example, human-to-human collaboration? Because if you think about these processes, most of the experiments are system-to-user, but in reality, they're usually incorporated in a group. In order to investigate that, we set up a visual ideation tool called ImageSense that allowed several designers remotely to collaborate with a virtual agent. Designers had further at hand the semantic search I presented before, and some other tools like image galleries to browse images. So to conclude that, in a study with 9 professional design teams of 2, we saw that designers associated clear needs, times in the process, and tasks with the available tools that were quite independent of the collaborator. And what I mean with that is that one designer, for example, reported that discussing ideas is easiest with your colleague. However, if you feel like something is missing, you don't know what, it's really hard to sometimes search or discuss that. So in this case, intelligent tools actually gave a helping hand and pushed forward. And so in the end, we overall saw that these interactive intelligence systems played rather a complementary role to the other designers than replacing one, which was very encouraging. And with that, we started investigating this further in a micro project in work package 3, where we actually also want to dig deeper into the underlying process of agency and how agency can be defined in the context of this interaction, and how exactly it impacts the role such system can play, especially in the context of creativity, at least for my case. Thank you.
Thanks, Janin. Great talk. Let's move on to the next one by Silvia.
Thank you for the invitation, and thank you for the first talks, which grounded my talk very, very nicely. What I will present you today is Guide Me in the Analysis, and I will illustrate how visual analytics enriched by guidance contributes to gaining insights and doing better decision making. And my overall aim is that I first will explain you shortly what is my understanding about visual analytics. Then I will explain you what is guidance. And then I will illustrate with an example how guidance can be used. So, first, what is visual analytics? Visual analytics is the science of analytical reasoning facilitated by interactive visual interfaces, and it was defined in the Thomas and Koch book, Illuminated Path. And there is a European perspective which tries to illustrate problem solving with visual analytics. And the basic idea is that you have visualization and interactions. This fits nicely the interaction part to what we have heard before. And you have computation mining methods, which are enriched by human perception and cognition to gain insights. What does this mean? It should help us to study the science that studies visual techniques to facilitate the analysis of the data. What does this mean? We have, of the first side, we have the pure visual approach. The pure visual approach takes the data, use visualization, and use the perception and cognition that the users, the humans, can gain insights, finding, and knowledge. On the other side, you have the pure computational methods. You use any kind of analytical methods to come up with models, and then you use the output of these models for gaining insight, finding knowledge. And the clue of visual analytics is now that you combine the idea about the pure computational and the visual approach to gain better insights. And the basic idea is that you use visualization for better model building, and you use model visualization for better visualizations. And as it can be seen, this is very straightforward, but also very complicated. And to support this task, we define guidance in our approach. This was a joint approach with people from the Rostock University and the University of Linz. What is the problem here? Usually, if you have such visual analytics approach, the user and the humans are often overwhelmed because there are different kind of possibilities, which kind of visualizations you can use. There are different kind of algorithms for the model building activities that are used. On the other hand, these algorithms and the visualizations have different kind of parameters, and the users or the human don't know really what to do. And one possibility is the idea of guidance to support the users where to go next. The basic idea is it's not the static stuff, it's the process of intertwining visual and analytical methods that the users gain insights in a huge amount of heterogeneous data. What is guidance? In the definition, how guidance is a computer-assisted process that aims to actively resolve a knowledge gap encountered by a user during an interactive visual analytics session. Here, the most important parts are highlighted in blue. It's a process. It's not a one step. It's a computer-assisted process where if you know that there is a knowledge gap, the user don't know where to go, what to do next, and you support the user in the interactivity of such a process. We have defined a couple of different kind of aspects how you have to handle this guidance. I can't explain it in detail, but one important step is that you have a knowledge gap. This can be seen that you don't know the target, or you don't know the path where to go next. And then you have different kind of inputs, the tasks, the data, visual analytics methods, users, and infrastructure. And if you support guidance, you have different kind of input data, what you can use, data, knowledge, images, user knowledge, history, and then you need to communicate it in the way of different kind of answers or means. And the last part is that you can have different kind of degree of guidance. You can have prescription, direction, and orientation. This means simple, showing me where to do next, or prescribing what you should do next. This is based on a model, which is in the visualization community quite well known. It's the Van Wyk model, and we incorporated in this model the guidance aspects. Orientation means where can I go? Direction means where should I go? And prescribing means take me to. What should I do next? To illustrate this a little bit in more detail, I give you a short example how you can tackle this. If you have, for example, the problem of you have a time series and you want to find circular patterns. What is the best circular for a time series that you can observe repeating patterns? And a solution could be that you apply statistical methods, or you support or you show interactively what could be particular steps. But the most important part is that you don't know a solution in advance and you need to get some hints. What is the basic idea? That the knowledge gap is that you don't know the target, you don't know which parameter configuration you have to use to find a cyclical pattern, and you have the data. The next one is the input, the data itself, the time series, and then you have different kind of algorithms which you can apply. But the problem is you don't know really which kind of parameter you should set that you find the appropriate cycle and encode this in a spiral or a slider. And the output in the sense is that you it's the most basic degree of guidance is orientation, that you get some illustration how to find good patterns. For example, here you could find good patterns if you look at this blue parts, and the spiral is that is the kind of visual representation of the guideline. How we encoded this, or how we did the guidance, we used a particular slider who can support you with this guidance. Usually you have a normal slider, then you enhance guidance in the slider, that you use different kind of algorithms to illustrate which kind of parameter settings would result in which kind of circle. How does this work in practice? You have the slider and you can move the slider around. And then you see here on the right side, you see the different patterns, and then you see a glow. You illustrate you how far you or how close you are. Oops, sorry. And this is how the whole system works. Here you have the slider. Oops, should start, sorry. And then you can move around. You see the different spirals and how they are moving. You can see the different kind of calculation and what it would be the best part to address this. Okay, this is just the beginning of our research, how we can incorporate in guidance in the whole process. There are a couple of open challenges. For example, how to detect the knowledge gap. It's not easy to know what is the knowledge gap. How to find the appropriate degree of guidance. What is best? Is direction better? Is orienting better? Or is prescribing better? Then what is the appropriate timing to do this, to provide guidance? And how should be the interactivity? And also the last challenge is how to open this black box, how to support the real process. Then you could also make an explicit model which could incorporate it to improve the guidance process, that you have more modeling about the user, the data, the task, or some biases. And another very critical aspect is that you can really evaluate. We heard about evaluation already, the effectiveness. And the last one is the comprehensive guidance approach. And the final end would be that we have guidelines for guidance, but this is the first step. Thank you. A lot of people to thank. And thank you.
Thanks, Silvia. That was great. Okay, we have one more talk. Mohamed is up next.
Okay, so start share. Should be fine. You see the screen?
Yes.
Yep.
Okay, full screen. Okay, great. Thanks for the invitations. So thanks for organizing also this. Oh, maybe. I don't think that you see that in the full screen. Okay. Okay, you see the full screen. Yes. Okay. Okay, good. Maybe I can put that here. So the what I will discuss maybe today is social learning agents. So it's a kind of collaborations that we have with agents, and more specifically, I will focus on the role of human behavior. So some assumptions that might have been said in other ways with the colleagues before is that we have humans and agents that are sensing and acting in the same environment. In the case of what we are doing and what I'm doing in my group is agents that may have usually have embodiments, because we deal with robots, for examples, but could be any kind of agents that could act and sense in the same environment. Some of them, and most of them, there is no necessarily they will not have exactly the same skills as humans, because as it has been discussed before, we are dealing with co-adaptation, and this idea and the adaptation and the collaboration doesn't mean that they have the same skills and they could do exactly the same thing. Here I will focus on the kind of specific loops that we have, is that we have the human teacher, and we have what we call teaching signals. I will describe that later. And we have a learning agent. So this is this kind of specific loop that we have. And it has been discussed if it is on the loop, out of the loop. We will see that we have examples. We have a lot of situations where both are learning. I mean, the teacher, the human, and the agent. I will show very briefly at the end one of the applications. So we deal here. What I will try to show you is a one way, is trying to see how the human is changing his behavior while he's interacting with learning agents. And this makes a lot of troubles for the learning agents, but it's also interesting from the human point of view. So we deal with what we call interactive task learning. So it's a process where we have an agent that learns a task, but it will learn also to communicate about the task. So this is also really important, and this is done through natural interaction. So in the literature, when we look to human teaching signals, they could be, and usually they are multimodal. So humans can use any kind of signals. So usually we switch between the modalities in different forms, like having a feedback, so learning from feedback, learning from demonstration, or even instruction. And the idea is that this kind of teaching signals could be more or less informative by being explicit or implicit. And what I want to show you today is that something that is important is the intention of the human. So there is an intention, and how this intention is expressed in terms of behaviors is really important. And one point is that, okay, the human has a kind of intention, but this intention is communicative. So we want the human wants to communicate something to the agent, but the point is that the agent has no really access to this kind of of intention, or partially have access to that, and this will make a problem of a loop. And in the loop, so we have a human teacher that has kind of intention, the learning agent has no not necessarily the good interpretation of these teaching signals. Then we will have a feedback to the human teacher, who will then adapt to the signals and change that again. So this creates a loop, and we will exploit a bit of the dynamics of this loop to create the communication. So in some way, what we want to see is what are the strategies done by or followed by humans to teach this kind of agents, and to see what will be the impact. So just to give you maybe very briefly some examples of the literature, maybe I don't know if you have seen this kind of works, but this is a very simple work that has been done by some colleagues in US. So what they have been doing is that, okay, we have some images that you could see here, different kind of images. So in this example, what they have been doing is teaching robots to by taking examples. So we have a list of pictures, and you want to teach a robot what objects are graspable and the others that are not graspable. So this task is might be there are really obvious. Let's say you take you take a table, you take a very big table, or you take let's say a very pen or something like that. You have very clear examples. Of course, you have examples that you can decide this might be graspable or not. But this is a supervised task, so it's not very complex in terms of. But what is interesting is how humans are teaching that. Okay, so in terms of machine learning, this is a binary task. But then when you look here, I just put some pictures of the article. So you have I just pick up some strategies of humans. So you have humans that they can provide extreme. So they give only extreme examples. Okay, you see examples that are not at all graspable. Okay, so the idea is that you have this extreme strategy. You can have also linear, so moving from one to one task to one class to the other class, or you have also people that are providing only positive. So it means that for the same task, which is a binary task, and this will have a clear impact on the machine learning side. So because people will not, the agents will not learn in the same way. So what we have been doing and what I'm doing in my group is based on mainly on social learning. So here I put a kind of definition of social learning. You might find others, but this is a kind of consensus on that. So this is social learning is any process through which one individual, so the demonstrator, influences the behavior of another individual, so the observer, in a manner that increases the probability that the observer learns. So what humans are usually doing is, okay, I want, so it has been studied a lot in developmental psychology, and in my group we have developmental psychologists also, and what we have been doing is to check how humans are trying to influence the behavior of the machine. And of course, we are doing also the other part, but here in how the machine can also influence the behavior of the human. But here I would just focus on one of the aspects. So the influence that we focus on is what we call non-verbal behavior modification. So you can use that, for example, to highlight a goal, okay, to say this goal is really important, or to highlight a kind of actions to perform a goal, or all kind of causal relation between the actions and the outcome. So to give you examples of what have been usually done in the literature, what we usually do is, for example, here there are two examples. One is called acoustic packaging, is that you want to show something. You want to show something to children. What you do usually is that you have the movement and you have the prosody. Okay, let's say take this one, or this is black, this is blue. You synchronize in some way the movement and the acoustic features to show that this is important. So you have a stimuli, so you have a lot of information in front of you, and by doing this kind of packaging, you show that this is important. On the right, what you see also is an interesting work that has been done by some colleagues here also in US. You have a simple task. So in Maze, you have a starting and a goal, and what you have to do is to perform the task. So in the doing condition, you just have to do the task. So okay, I do the task, I go there. But now if you have to explain or to show the task to someone else, you do things that are not useful at all for the task. You see here, they do things that are not useful at all. They change the behavior. So in terms of learning, if you have to learn, either if it is a machine or if she or he is a human that is learning from that, should I learn from the showing or the doing? The doing is efficient for the task, but the showing is also explaining things, trying to explain that, okay, these are the stuff you should not go there, and these are the possibilities. So we are interested by this kind of behaviors in humans when they teach machines. Okay, so to make it very quick, to give you after some examples, our vision on that is that we introduced a kind of, we have the human, we have the teaching signals, and we have the learning agents. We introduce an interpretation phase that you could think about trying to translate the teaching signals in terms of intentions, but also kind of filtering the actions of the humans that will be useful for the learning agent. So here I will very briefly show you 3 examples. One is learning from non-optimal teacher. So you have a teacher that is providing teaching signals, but they are not optimal for the task. They might be wrong, for example, and you need to interpret that. We have another example from trust. Usually we focus a lot of human trying to how human can trust machines. Here what we did is that could we trust all the teaching signals? I mean, there might be non-optimal ones that might be wrong. So how we can deal with that. And the other one is we have a situation where we don't have a teacher, but we just observe someone else, okay? An actor, someone doing something that makes sense for me. Okay, so for the first one, you have so it's in the reinforcement learning framework. So you have a robot that is performing a series of actions. So you have to learn actions, for example, going from blue, from green, and then pink. But you don't understand the instructions. You have instructions, but they have no meaning for the agents. So what is the aim is to learn the meaning of signals. I see something, but I don't know the meaning. Usually people in robotics or in agents, they script that. Here what we did is that we didn't script. We see agents performing, humans are performing gestures, but we don't know what they mean. So just to briefly show how it works is you have the standard reinforcement learning where you have states and you move to actions. Here what we did is introducing these instructions and this meaning of that. So we do interpretation of that. We have states and actions, and between that we have 2 learning processes where we learn to interpret what we see on that. I will skip the details or technical details on that, but this is quite interesting, is that we are able to learn on real time what humans can want to show by the kind of instructions. The second example is an example where you have teachers and they still provide instructions, they provide feedback, but now we want to filter a bit the instructions of the teacher. We will not exploit all of them. So this is basically done by mechanism where we try to compare what the human should provide to me and what I should and what he is exactly providing now. And by doing that, I can have kind of competence of what I can do by myself, what the human is doing, and we introduced a kind of trust let's say, modeling on the actions, on the policy of the human. And by doing that, you can by sometimes ignore kind of actions of the human. Still, we don't have necessarily too much time. I will move to the last example. In the last example, what we did is that, okay, I have an agent that we have different agents, and we have Bob, who is an agent that is not teaching, is just doing things. So I see the agent doing different kind of action in different environments, but he's not teaching at me at all, and I don't have necessarily the skills for doing all the actions that I observe. It is exactly what you could see with children and adults. You have children that they observe humans. They don't have exactly the same skills. For example, you observe that you open a door, but you are not able to open the door, for example, but you see that. So in this kind of task, what is interesting is that you have different ways of learning. One way could be to be autonomous. So I don't care about what I see. I just try to do it by myself. Second one is imitation, trying to reproduce what the others are doing. And the third one is really important in the way we try to combine this learning, is what we call curriculum learning. Is basically what is important is not what you see or what you observe, but what is you observe that you could really do now, and what is useful for you right now for the task. And by combining this kind of mechanism, so autonomous learning, imitation learning, and curriculum learning, we have been able, for example, in this kind of scenario, you to have agents that sometimes, so you see here different the competence of the agent that is learning, and you have a Bob that is performing different kind of demonstration. Sometimes no demonstration, so you learn by yourself. So it's autonomous learning. So it takes time, but you learn. You have demonstration on some of the objects. So you have 6 objects here, but you have demonstration only on 3 objects. So you are learning. It's slow, but you still learn. And you have demonstration for all the 6 objects. So it is what we the optimal situation where you could do imitation. And what is interesting is that by combining the mechanism of autonomous learning, imitation learning, and curriculum learning, we are able to, sometimes to also ignore the kind of behaviors of the others. So last thing that I want to tell you is that we have a lot of applications of that. One of the applications that we have is in education, and we have been developing social learning in this situation. And so in the same line of what has been discussed today is that we have in pedagogy what we call learning by teaching. So it's when children are learning by teaching the others. That's the idea. And what we do is that we have children that are learning, for example, any concept, mathematics, writing, or others. And in this case, they teach the agents. And here you can see that the children that is learning is not expert. So we have to efficiently learn a task. But in the same way, we need to ignore some of the signals to learn the task, but also to provide feedback to the children, so the children can really learn some new tasks. Okay, so just to summarize, so what we are doing and what we try to do is we in the collaboration we think that non-optimal experts or users are probably this is not an exception. There are a lot of situations where we are facing that, and this is it has already a clear impact. Here I put robot learning because it's what we do, but I'm sure that in a lot of AI, human AI interactions, we will face this kind of problems. And in our case, we need to learn from few data, non-optimal teachers, but we also what we are trying to do also is to improve the transparency of our learners by explicitly saying that they don't know about the task. Okay, so that's all for me, and thank you.
Thanks, Mohamed. And
Mm.
thanks to everyone, all our speakers today. That was the end of the talks. A big round of virtual applause from my side and from everyone, I suppose. I see that we have already crossed the planned end time for this event, but I'm glad also to see that we still have about 54 people here. So let's have a discussion. Whoever's free to hang out and stay on for the discussion, please feel free to join in and jump in with your questions or points. And I think all our hosts and speakers are still here as well. Kim already has a question, so go ahead, Kim.
Yes, hi. I had a question for Mohamed. Thank you for the presentation. This was really interesting work. I have a question about the idea of a non-expert teacher. So there's often a distinction that tends to be not spoken about, which is expert at a task versus expert in teaching, right? Like I can be really good at a task, but I can be really bad in actually teaching another agent to perform that task. So I was wondering if you thought about that distinction and if for the types of tasks that you're considering, if it really matters whether you are an expert at the task and also an expert at teaching or not that much.
No, exactly. I think the talks were short, but one thing that I'm doing is that we claim that we could separate the social channel and the task channel, and and it's why I was saying we learn both to perform the task and to communicate about the task. And from the human side, we have exactly that. So we try also to, and this is really interesting because with children, and I'm working a lot with children with autism and spectrum disorders, and we have this issue, exactly the issue you said, is that we have some of them that they could do the task, but they can't explain at all, and we cannot teach at all to do that. And this is interesting because in our mechanism, we use that to assess this kind of stuff. When the communication is failing, this is really interesting. For us, it's not, I think it has been said today, having systems that are not working, this is useful because you learn about something. We use that to assess also the communication problems.
Okay, thank you.
Thank you.
Great. Questions to any of the speakers, please go ahead and shoot them out now. Also, speakers, you're free to also ask each other questions about your talks or start other discussion topics on this topic. I, of course, have many questions myself, but I don't want to take up all the space. But maybe if nobody's asking yet, maybe I'll start with one, which is going back to the very start where Wendy and Andres were talking about the application or the output versus the interaction. And I think this is common, like in all our cases when we're developing interactive systems. So there's, of course, like how the user, be it the designer or the end user, interact with this tool versus what they can achieve with it. They're not always independent of each other, of course. So the way I interact also affects what results I can produce with them. So I was just wondering how everyone approaches this when doing your own research. So do you start off with the objectives from the output perspective, or you really think about the interaction first and then think about how much output or performance improvement, say, you could get out of that system?
I can try here. So we're very human-centered. So we go and we actually watch people, we do workshops with them, we do participatory design or co-design if you prefer, and we spend a lot of time trying to figure out what they're trying to accomplish and what they want to do from their perspective. And then frankly, we take whatever algorithms are out there and we try to fit them in. And so there's mushing around with algorithms, of course, but we don't start there. We start with the human and what it is that they want to accomplish. And sometimes it's not a measure of performance. Sometimes it's a measure of expressivity or creativity or pleasure of, and Janin has a really nice example with, creating interactive mood boards where the goal is not to get more images faster. It's to get the right images that evoke the right feelings and, iterate with that over time, both with the system and with the user. So it's not a metric about performance necessarily. Sometimes, of course, we care about performance because we don't want to slow people down and make them bored and so on. But it's not the primary metric usually when we're dealing with, certainly when we're dealing with creative professionals, which we do a lot of.
Yeah.
I agree. I was saying about the work that we are doing, for example, in clinics. In clinics where with children with autism spectrum disorders, what you DM is it's what we call robot centered. It's in some way is that what you do is not comparing machines in clinics. You compare groups of people. So if this is only a mean, so if they have less performance or better performance, it's not. Don't try to optimize that. What you want is something that you could use, and you are really confident that it's providing you the metrics that you want. And for us, the metrics is more important than really the performance.
Yeah, absolutely. I think this also ties in with the way we evaluate our systems finally, because like both of you mentioned that we are focusing really from the start from how in a human-centric way, how we are going to interact, but then quite often then our evaluation relies on the success, or at least that's how we justify that in our paper. So there might be like some conflicts there as well.
Can I say something about that? Because well, all right. I mean, Janin, but we'll say something similar. I'll say it super quick. We actually measure human performance, and that's what counts for us. And in a weird way, if the algorithm is slower, but the user is better off by whatever metrics we chose, which might be expressivity or creativity or something else, that's fine. So we don't necessarily need. We're very happy that there are people out there making very fast algorithms. Great, but that's not what we're measuring, and that's not what we get evaluated on in our papers. And I think it's important that people on both sides of this divide understand that there is another side to it, right? And so we can respect the fact that there is this performance benefit for faster algorithms or whatever performance metric there, but it's not the only metric. Sorry, Janin, I saw that you had your hand up too, so.
I think it's very similar, especially I think when you look at creativity, which was a discussion in general, understanding what is more efficiency or like what is a better result is in general very complicated. Like what is a better idea? And there's actually a lot of research out there that it's not sufficient to measure the number of ideas because they can be all not really good. So it's kind of, hence like what I take, and I think we in general in the lab here is very like process oriented approach, kind of like creativity as a process. And what we try to achieve is to make it easier, more enjoyable, more expressive, that designers find what they want, and all these kind of things together with systems. And if we achieve that, quite often through a mix of qualitative and quantitative measures, we kind of try to validate that, then we kind of succeed, because the end idea depends a lot on who's doing it, for what it is, and how it develops further. So that's kind of, I think, I take on that.
Yeah. Jacob, I see you want to jump in.
So I didn't find out how to raise my hand. Sorry, so I just did the physical way.
That works.
Can I just ask all the participants, maybe also present us to a question? Have you ever run a study in which explaining the particular mechanics of the algorithm underlying it can be used as a means of sort of soliciting better input on the human side? So of course you always run a tutorial, so how to interact with the system, but have you tried sort of to run a systematic study where just informing about what kind of processing is done on the other side of the system allows for this thing of like a theory of mind or intersubjectivity, you to understand much better how you could interact with the system?
I hate to just jump in, but I'm bold, and I'm a native speaker, so it's easier for me, so I will. Yes and no. So in general, if you look at the example that I showed with Field Forward, where you've got this interactive colored heat map, and the system is gradually showing you, oh yeah, I recognize that, oh no, I don't recognize that, and so on. And then people sort of learn things about it. So it's indirect what they learn there. I do have a student, Teo Sanchez, who I co-supervise with Baptiste Carmio, and he's working on machine teaching and actually trying to find out how people who are trying to teach an algorithm understand the way the algorithm works and the kinds of errors that they make and so on. So that's actually fundamental to his thesis. And I think there's some interesting things, but by and large, I'm going to say something that's very controversial to a lot of people, which is that a lot of the work in explainable AI, I think, is not going to help human beings. It may be nice for other people for other reasons, but usually people do not care how the algorithm works. What they care about is, how does that algorithm affect me? What does it enable me to do next? So like the feed forward of various kinds and the feedback, what is it understood and what is it doing? And how do I interact with it? Which is a very different thing than trying to explain how the algorithm works, which often is not something that's explainable at all, because it's kind of a black box. So anyway, I realize that will drive some people crazy, but that's all right. That's my job.
So I guess it depends a little bit how complex the interaction is. Can you just show what the machine would be computing in the next step by a couple of interactions, or is it something sort of more deep within the sort of the calculations inside? The reason I ask is just that our learning scientist, Arthur, who's also on the call, is teaching in high school classes politics, and then having Twitter AI sort of like Twitter feeds, and then a part of that is sort of teaching them how the natural language processing works, but it's also a part of understanding how to interact with the system, where you can understand sort of what the politics of the tweets are. So it's sort of integrated, learning about the algorithm and learning about the topic, which is something different. Sorry.
No, but I also think that there's one thing that's important to add about that, and that's the sort of, I'm sorry, I see some hands up. Is it okay if I just elaborate, because it's specifically about my work? So so far we can do it with very simple classification algorithms, right? And so if the rules are simple, right, basically Bayesian classification, can we describe how you take probabilities and then find the averages, then we can break it down. How we would do it with more sophisticated neural net structures and showing them graphs. You know, Wendy, we've probably all seen these NVIDIA AI maps where we can see, oh, this part of it gets at this part of the image, and how, like, whether that would help high schoolers, I also sincerely doubt that. So there's definitely, like, I think we can get some part of the way with explainable AI, but I think it also is, but I think it's easier to do with things that can be broken down into relatively simple sets of rules, and not the big, pure, you know, gradient descent graph stuff. So.
Thanks, Arthur. I see Michael, you're up next.
Thank you. I have a story to tell. I'll try not to make it a long story, which is, I think, connected with this, but in an odd way. We were doing a study of AI-assisted software translation from Java to Python. And we worked with software engineers who, not researchers, but engineers. And we said to them early on in this study, well, would you like to know how it works? Would you like to have an explanation? And they said, absolutely not. I'd just like to get my job done. Thank you very much, all the same. Then we presented, we used generative methods for making the code translation. I'm sorry, and my phone is ringing. I'm going to get it away from. Oh, and they didn't know that. And so we would then show them a translation, and we would flag the sections of the code that had the least confidence, some of which were just open curly brackets, which then confused people. And they said, well, why is that? And then the next deeper version of this was to show them the alternative translations that occurred at that point. That, of course, became an explanation, but wasn't what we intended. And then they could choose one of those alternate translations, and it would immediately go zoop into the code. And so the translation actually became a tool. It became an actionable tool in the UI. And that turned out to work very, very well, even though they hated the idea of being lectured to about an explanation, for whatever that's worth.
Thanks, Michael. Alessandro, you want to jump in too?
Yeah, I wanted to pick up also on Jacob's question. I don't know if it is directly relevant, but something interesting that we learn in the field of elderly assistance. We actually worked a lot on creating social robots for elderly assistance and evaluating social robots for elderly assistance. And in that case, we found out that explaining something to the subject about, well, of course, not about how the robot works, but about the weak point of the robots, about how the robot fails, actually, on which parts are more robust and which parts are less robust. Well, this turned out to be very important, probably for two reasons. One, of course, is to improve the interaction. So the subject knew that if the robot asks you a yes/no question, you are supposed to answer yes and no, otherwise the robot will be confused. But what is probably more interesting is that it was very important for the subject not to get the feeling that when something goes wrong, it is their fault. Not to get the feeling that they are not able to use the robot, that they are somehow, sort of this sense of inferiority. On the opposite, by explaining what are the technical weak points of the robot and explaining also that the robot is still improving, is still a prototype, they felt sort of motivated to help the robot improve itself, something like that. So that's a case where giving some sort of detail on what systems they were interacting with was actually very important, we found.
Yeah, thanks. So Andras, you had your actual hand raised up before, so go ahead.
Thank you very much. So for me, from the point of view of explainability, the question is not how the system works, but how it has come to a given conclusion. So from the point of view of the mystery of intelligence, the question for me is that having 20,000 years of mankind and many, many people, what we have learned in the scientific domain, that knowledge can be given to a child, not all of them, but large part of them, in about 20 years. So it cannot be too much, and there's a specific method how we do it. And that goes back, in my view, to the complexity of the problems to be solved. There are different problem types. Some of them are easy to solve or hard to solve. And out of these two, the solution sometimes are easy to verify or hard to verify. And from the point of view of intelligence, the relevant parts are those which are hard to solve and easy to verify. And these are the ones that are worth to communicate, because then I give you something in a very short time that will help you, because you will not have to solve it by yourself. And if you consider about theories, mathematical theorems, the proofs are along a line. They are linearly structured, so they are easy to prove. At the same time, the search was in a combinatorial space. Same holds for scientific papers. Those are also structured along linear lines. So this is the basic principle where I see the point for intelligence, and that's different from learning the skills. So I would like to separate the procedural learning from the declarative part of learning and the episodic learning. And out of this, the latter one is related, in my view, to intelligence, whereas procedural learning is not. I mean, that's a different story. Thank you.
Thanks, Andres. Mohamed, you were up next. And then
yes. Yeah, I would just wanted to say that there are situations where it is also important from ethical point of view to explain that at least not the details, but at least that there is a learning system, and and also, as Alessandro was saying, this could help. I said about the learning by teaching. This is maybe what you expect, what you have been doing maybe most of you have been teaching also, and this is something that we are doing. But when you do that with agents and mainly robots, it is in particular with children, it is also important to explain that this is an agent. This is an agent that doesn't have the ground truth. It's not. It's an agent that is learning. So it's and this is something that you could do with a robot. You could expect mistakes. You could expect exaggerations, and at the end, this is also important from the ethical point of view. And we see that with children, they are more engaged because now they understand that this is a learning system. So if I'm doing something, I see the impact. So this is basically like no feedback and things like that, because I see the results of what I'm doing. So if the children is doing something, it sees that because he knows that or she knows that this is an imitation learning or things like that. Doesn't know, as you said, maybe Andreas, you don't know exactly how it works, but you know the effect on that. That's important. And you know that if I improve myself, the robot will be improved. So this is something that we should also explain we recently did a paper and we put as a quote with children with dysgraphia, so really serious problems of writing, and we put in the title of the paper the quote of the children, and it says, I'm putting that it is not the robot who learns, it is me. That's what the children are saying, because they know that at the end there is this complex loop that we discussed today, but there are these complex loops, and we should be also aware of that, and also make aware the users of it.
Yeah, absolutely. Yeah, I think that's an important point, and I also think that these explanations especially become important when the agent does not really agree with you or confirm your prior beliefs as well, and tries to suggest alternatives. I think that also kind of reminds me of Janin's talk, where she talked about collaboration between humans and how disagreement is quite an important part of the ideation phase. And quite naturally, we as humans, when a machine tells us you're wrong or not, you do not have full information, then we tend to reject that immediately. So in those cases, I think handling this kind of disagreement becomes quite important. Janet, you had your hand up earlier, but not anymore. Did you still want to say something?
The conversation is going on in the chat, so there's no need for me to ask it here. I think it got resolved.
Yeah, more questions on Janin. I see you want to jump in.
Sorry, I can also just press the button. Yeah, actually, I think it's a super interesting conversation that's like between the chat and here about explanation. So in the context, of course, of my work, I actually looked at what is actually interesting for designers to know if the system suggests a visual idea. And I tried out different methods, basically explaining how it fits to the collage you're building, explaining what it means itself. So, like the discussions with designers afterwards, there was like, basically what I extracted of it, it's way more about what the agent does to what I'm currently trying to achieve than what the system decides in the background. I mean, in my case, it was kind of, if it now explores or exploits and why and the probability, and that's usually not interesting for this interaction. It's more, why should that be relevant to me? And I do think that we are probably also talking about different situations. Like, I think teaching, for example, is a very different situation. You might want to understand more, but as an end user who uses one of these systems, we might actually have to go away from explaining what the system does to what the system basically contributes to what I'm doing and how is it relevant to me. I think it's like there are different things. And then in the chat, we actually went to, well, if the system makes decisions about health, police, whatever, I want to know how it's used. So I think there are different cases.
Yeah, absolutely. Yeah. Yeah, I think there's so much to discuss on this topic about usefulness, or how can you make explanations more useful. And especially in closed loop interactions or human AI interactions. I see that we are at 1:30, but we still have people here, so we could continue the discussion until people are here, if that's okay with everyone, unless you really want to end the meeting now. I have several topics to bring up related to creativity and learnability and other things. So I guess, okay, maybe I just bring them up and then we'll see who stays on. Okay, the next one was coming to my head was about learnabilities. We touched upon that in several talks, starting from Wendy's about how people could actually learn gestures and things like that. To later, Alessandro, you talked about how humans basically can guide robots, for example, to collaborate with them. And also, Mohamed, you talked about using this kind of demonstration and other techniques for teaching agents. And I was actually thinking about it from the other way, about how we can actually learn and how human AI systems can help us learn both the interactive systems better themselves and also our tasks. So that's basically the backward arrow, instead of going from the human teaching the robot or the AI or the agent to the agent teaching the human, and how that can be facilitated. So I'd be interested to hear anyone's thoughts on that topic too.
I have a thought, but I don't know if it's I think someone asked I think Mohamed about this question of like the separation between expert teachers and content experts. And I think maybe most people are familiar with that, with the Schulman's idea of pedagogical content knowledge. And it made me think about, like, what is it like? Is that a thing for teaching machine learning or models? And I can't tell if the analogy really holds up and whether we could or should think about it that way. But there was just something funny about how, like, we clearly have content experts. We have coders who are just, good at, machine learning engineers. But is there a sense of being good at training models to do specific things? And is that like a hybrid intelligence for machine learning, pedagogical content knowledge? I'm not sure whether it's worth talking about, or it's like a red wine conversation kind of thing, but that was a thought I had.
Yeah.
Yes, you mentioned the pedagogical. I think that's really really interesting, because we saw that in a lot of situations that people with the intention of being pedagogical, they change, and sometimes the change is not optimal at all for the task. But it's and this is really interesting when you have exactly the same channel to do the task and to do the communication. That's really interesting. Writing, for example, when you look to writings, sometimes you exaggerate things, and this is not useful for the task. So as a children, or as a human, or as a robot, a machine, what should I learn? Exactly the mapping, or how I can separate from the channel the communication and the task. This is exactly what we are trying to face in terms of problems. And this is really fascinating, because it depends on the intention, but the intention depends on I think it has been mentioned before about the theory of mind, and because most of these kind of models have that in mind, is that you try to think about like what Wendy was saying about the machine teaching and things like that, is probably also what I should give in terms of examples. That's and how I should do that. And I'm really interested in the way of humans doing that in the same communication channel. That's very fascinating.
Absolutely. Yeah, Wendy.
Just very quickly, I've just been reading by chance some interesting work by Alison Gopnik, who studies children and learning and so on. And one of the things that she's shown with very young children is that it matters to them who is telling them stuff. And so if they see another kid, it's different than if they see an older kid, it's different than if they see the teacher. And so there's an interesting question about how do humans treat machine teachers? Like, do they, and there's going to be something very interesting going on. And this is pretty fundamental at a very young age, that they start reacting very differently. Even infants, they can detect differences. So again, not my area of expertise, but I think there's some really interesting questions there.
Yeah, absolutely. I think, Mohamed, you talked in your talk about learning from non-optimal human teachers, how machines could do that. And something that struck me was that learning from non-optimal artificial teachers could also be something quite interesting, and how this kind of intention.
It's what we are doing now. Because now you could, I'm not saying easily, but you could do that, like agents teaching other agents, or having a mix of all of them, and that's what we are trying to do. We have some and this is also related to the way of trying to have models of the others. And when you have models of the others, there are two questions. One is what I should provide to the other in terms of teaching signals, and for the learner, from whom I should learn. That's a question, because the word is so vast. You may have a lot of inputs. So it's what we have an experiment that is exactly that, is how to do that. Actually, it's learning to with several modalities: feedback, demonstration, and even linguistic information, instructions, do something. And we are adding now explanation, but explanation is quite hard because it's, as it has been said, it happens after the actions. So it might be something that we are still investigating. But that's a very, I think Antti, I don't know, he mentioned very early on during the workshop today about an initiative that is called Cooperative AI, and I think that's what it fits. It's to I think they call it the science of cooperation, is and trying to what I like is really that now we have the tools to investigate humans interaction, human machine, agent and agents, but at the end what you really try to investigate is the cooperation.
Absolutely. Maybe related to that, I had also a question for Alessandro, related to your work with the robots and how humans basically interact and collaborate with them. Did you also think about the feedback from, I think you briefly mentioned it in your last slide, but about kind of feeding back from the robots' actions itself, where they kind of had the freedom to manipulate what they were doing or kind of vary what they're doing, and how that could affect how the human piano player, for example, was conducting themselves?
Yeah, we discussed it a lot with our musicians, friends, actually. That part, and that's something we'd like to explore much more. But for now, basically, what we notice, in fact, of course, it's not built into the system, but we do have a system which is a little bit anticipatory. So sometimes it tries to anticipate what the player might be doing and to actually react to that. But it does it in stages. So it's sort of, there was a passage, for instance, where the system proposed some sort of variation in emotion in playing, the drummer it was. And then in one case, the pianist did not take the suggestion actually, so he kept going on a smooth tone. And in another part later on, he sort of took the suggestion, but this was sort of, say, subconscious or not fully conscious from the pianist. When talked to the musician, then actually, they came out with this thing that some mechanism which is clearly much more primitive, but somehow similar to these mechanisms that actually happens between human musicians, where somebody may put a suggestion forward in jazz, especially, and then you may take it or not take it, and then maybe change it in some way and so on. Well, the pianist was feeling that something like that was happening with the system. I think what was very interesting in our opinion, and also for our musician friends, was that this system is not learning. There is no no adaptation on neural network and nothing in it. It's just a model-based fuzzy system, actually, with some randomness in. So some of the things are actually chosen randomly. So all the adaptation happen basically because the musician is changing attitude and is little by little adapting to the system in this current version. I think it's really a start, but it's a very fascinating.
Yeah.
And also, I wonder, since there's this loop, when does it happen that actually we are lucky as the musician and the dancer or the drummer sort of converge, and when the full system will diverge instead of we oscillate or we do something different?
Yeah, I think the domain itself is really fascinating for this kind of work, because there's also room for a lot of flaws that can actually influence the artistic style as well. So I think that's super cool. One of the musicians that I really like also has this system where basically he plays the piano and two other pianos kind of play off of what he's playing on their own using some algorithms. And that's really cool as well.
Can I just ask and follow up, Alessandro, because so do you think of this system as maybe a model of more complex real life interactions, right? Because what we talked about before was humans don't want to be told if the actions that they can get or reactions they can get from the AI is sort of pretty simple. But what you're talking about is really a truly complex dynamics that can become chaotic and can go in any direction, just like if we successfully implemented sort of a really good robot collaborator at a workplace environment where we could potentially go everywhere. And this is where the case was, where I was saying, if your participants knew a little bit about the randomness or a little bit about how often randomness comes, it could change their propensity to be adopting those choices, or maybe saying, oh, I will wait for the next one or something like that. So that's where diving into the machinery, if there is not just first order, but also second order sort of derivative effects coming in.
Yes, but this was an interesting thing, that we mostly work with one kind of player for that. So of course, this pianist already didn't know the technique, but he knew what sort of knowledge we put into the system. Mm-hmm. So at some point he thought he knew a little bit how to control the robot or how to control the drummer. But that's why we actually tried with another pianist after that, who has never seen the system before. And the interesting thing is the interaction was still very good with the second pianist. I mean, in fact, with three of them who didn't know about the system, didn't know what was inside, did not have any previous experience. And also that the first pianist, he mentioned several times that he was still surprised by what the system did. In fact, he said several times that he found that playing with this drummer was actually more surprising than playing for a human drummer. It was less predictable in a way, which of course is maybe good and bad. So as you say, it might actually lead to a sort of semi-chaotic interaction in some cases.
Yeah. I think that's a great point, Jacob, as well. It really makes me gives me a tangible thing to think about, like what you meant earlier on with the question. That's really cool. Okay, anyone would like to bring up any other topics? We still have a few people here. I guess most people have had to go. It's late, I do understand. I had one final question for Jacob, maybe, and Janet, but Janet's not here at the moment. About your graph or kind of map that you showed, where at present we are in the loop, and then the next step that was predicted was on the loop and then out of the loop, and you had this diverging path of going from in the loop to hybrid intelligence, right? I was just wondering, what are your thoughts or vision on maybe like one paradigm shift that's required to go from the current in the loop towards the hybrid intelligence step?
So I think that's a good question, and we may not be right in it, but what we think is that if we can provide sort of a framework for incrementally asking questions and putting several sort of what we hear at these talks is really fantastic examples but the generalizability of it is sometimes a little bit difficult because people are sort of saying, well, it was human in the loop, or it was a computer in the loop, or so we sometimes get stuck in sort of a little bit of a lack of notation for saying that it was, let's say, in a dream case, hybrid intelligence degree 5 or 6 or something like that, where it fulfills an increasing number of questions, and that we can sort of say, look at a system like the one Wendy was seeing, or Alessandro, what you were doing, and then we can ask concrete questions about the co-adaptation that is going on. And if a little bit more was going on, it may or may not be better, but at least we have pursued sort of those kinds of addresses. And I think that's what we meant about sort of trying to put a framework in place.
Yeah, so yeah, it sounds really great. I'd love to look forward to seeing what comes out of it and the next steps that you take as well. Hopefully we can have more of these meetings on this topic or similar topics, and you can join us too. These are always open events, so it'd be great to have you in the future as well. Okay, having said that, if we don't have more topics right now to discuss that is urging everyone's minds, we could end the meeting considering it's 45 past what was planned.
Thank you very much for organizing that. It was really great.
Thank you. It was awesome.
Yeah, I had a really good time. Thank you all.
Bye.